everybody. Welcome back to another video on climate and weather. One of the questions that I was asked recently is, why is it easy to predict 100 years of climate in advance but not 10 days of weather? Well, I would say that this is because weather is chaotic but climate is generally not. Now, what does it mean to have chaotic behavior in a weather system? So chaotic means extreme sensitivity to initial condition, which means if we have difference between two states to start with, the difference amplify as we go in time. Let's say I have equation. All our climate model and weather models are nothing but set of equations which which need some initial value or starting values and progress in time. Okay, so if two states starting at, let's say, t is equal to 0 and t is equal to 1, if these two states have very high sensitivity to round off error, which generally they do have, then these round off errors sometimes diverge the solution of the models. So weather is highly chaotic, which means that the two states diverge after a certain period of time while solving a climate model or set of equations. This is also called butterfly effect. Now, what does butterfly has to do here? Why is it called butterfly effect? A puff of air from a butterfly's wing, when it flaps its wing, the puff of air that go out of it can lead to very heavy storm somewhere far away from the butterfly. This is called butterfly effect because it is very sensitive to change in small initial conditions. Now, which means if butterfly never existed, there wouldn't have been any puff of air because of flapping of the wing of butterfly, and if there wouldn't have been puffed air outside the butterfly wing, there wouldn't have been storm somewhere outside. So if there is no butterfly, means there is no storm because of the puff of air outside it. So it's called butterfly effect. Well, it's not only butterfly that can cause storm. There are many other factors which are much more sensitive to cause that. This was first observed by Edward Lorenz while he was trying to find some weather phenomenon after some period of time. He was entering temperatures, wind speed values and so on, and he started with very little bit different condition from the previous ones, and he saw that his output of his model, output of the equations he was getting from his model was completely different. The solution completely diverged from the previous solution. That's what chaotic means. Now, because our weather system models are nothing but set of equations which are solved by computers for faster simulations, and these all need a starting point, which we call initial conditions, and these initial conditions generally come from observed data and previous results from the models. So if there is any change in previous or initial values, the model gives a very different output, even if there is very round off error. But when it comes to climate, all the butterflies average out. What I mean by that is, climate is actually predicting weather in long term, or climate is time averaged weather. So it doesn't matter if we are predicting some kind of storm on Wednesday and it happens on Thursday, because it's averaged for a very long time in future, maybe 10 years, 20 years, depending upon a situation of requirement. So climate is generally very accurate, but weather is not because of chaotic behavior.